From the moment the first light pierced the primordial haze, our planet began a relentless dance of fire and water, rock and air. Today, the blue marble we call home is a tapestry woven from billions of years of geological upheaval, atmospheric chemistry, and biological innovation. In this journey we will peel back the layers of myth and mystery to reveal the hard-won scientific facts that define Earth's past, present, and future. The story starts deep within the mantle, where temperatures exceed 4,000 degrees Celsius and pressures are 1,000,000 times greater than at sea level. Here, convection currents of molten silicate rock act like a planetary engine, driving the movement of tectonic plates on the surface. This slow but inexorable flow reshapes continents, births mountain ranges, and fuels the restless fury of earthquakes and volcanoes. Plate tectonics, first proposed in the mid-20th century, transformed our understanding of Earth's surface. The Pacific Ring of Fire, a horseshoe of subduction zones, accounts for roughly 75% of the world's active volcanoes. When one plate dives beneath another, water-rich minerals melt, creating magma that erupts as spectacular plumes of ash, reshaping climate and ecosystems in a single breath. Beneath the crust, the inner core, a solid sphere of iron and nickel, spins slightly faster than the mantle above. Its magnetic field, generated by the dynamo effect of liquid outer core currents, extends far into space, forming the magnetosphere that shields life from lethal solar radiation. Without this invisible shield, the delicate chemistry of our atmosphere would be stripped away, leaving a barren world. The atmosphere itself is a fragile, layered envelope composed primarily of nitrogen and oxygen, with trace gases that play outsized roles. Carbon dioxide, though a mere 0.04% of the modern atmosphere, traps heat through the greenhouse effect, maintaining a global average temperature that permits liquid water. Recent measurements show a rapid increase in CO2, a signal of anthropogenic influence that reverberates through climate systems. Ocean currents act as the planet's circulatory system, redistributing heat from equatorial suns to polar night. The thermohaline circulation, driven by differences in temperature and salinity, transports vast volumes of water through the Atlantic, powering the Gulf Stream that moderates Western Europe's climate. Disruption of this conveyor belt could trigger abrupt climate shifts, a scenario explored in paleoclimate records from ice cores. Ice cores drilled from Antarctica and Greenland preserve a chronological archive of atmospheric composition dating back 800,000 years. Bubbles trapped within the ancient ice reveal past concentrations of greenhouse gases, while isotopic analysis of the ice itself decodes temperature fluctuations. These frozen time capsules confirm that current CO2 levels are unprecedented in the geological record. The biosphere, a thin veneer of life covering land and sea, exerts a profound influence on Earth's chemistry. Photosynthetic organisms convert solar energy into organic matter, releasing oxygen as a byproduct that transformed the early atmosphere from toxic to breathable. The rise of oxygen, known as the Great Oxidation Event, enabled the evolution of complex multicellular life. Rivers sculpt the continents, carving valleys and delivering nutrients to coastal ecosystems. The Amazon, carrying more water than the next 7 largest rivers combined, deposits sediment that builds deltas and supports some of the planet's richest biodiversity. Yet satellite data shows that deforestation and dam construction are altering its flow, with cascading effects on carbon storage and climate regulation. Earth's orbital mechanics, described by Milankovitch cycles, dictate the rhythm of ice ages. Variations in eccentricity, axial tilt, and precession modulate the distribution of solar insolation, nudging the climate toward glaciation or interglacial warmth. Computer models integrating these cycles with greenhouse gas concentrations accurately reproduce the timing of past climate transitions. Seismic waves generated by earthquakes provide a window into the planet's interior. By analyzing the speed and refraction of P waves and S waves, geophysicists map the boundaries between crust, mantle, and core. The discovery of the low-velocity zone, a partially molten layer beneath the lithosphere, explained why tectonic plates can glide over a semi-fluid substrate. Human activity now rivals natural forces in shaping the Earth system. The extraction of fossil fuels releases stored carbon, while land use change alters albedo, the reflectivity of the surface. Satellite observations show that urban heat islands can raise local temperatures by several degrees, illustrating how anthropogenic modifications feed back into the global climate. Yet the planet is not a passive victim. Resilience is embedded in its feedback loops. Clouds can both cool by reflecting sunlight and warm by trapping infrared radiation. Forests can sequester carbon, offsetting emissions. Understanding these complex interactions is the frontier of Earth system science, where interdisciplinary models strive to predict the trajectory of a warming world. In the final analysis, Earth is a dynamic equilibrium of forces, geological, atmospheric, hydrological, and biological, each interwoven in a delicate balance. The scientific facts we have uncovered illuminate not only how the planet functions, but also the responsibility we bear as its most influential species. The choices made today will echo through the strata of tomorrow, shaping the very story of Earth itself. Beneath the ocean's surface, phytoplankton perform a silent alchemy, converting carbon dioxide into oxygen and forming the foundation of marine food webs. Their minute existence dictates the health of fisheries, climate regulation, and even the atmospheric composition that sustains terrestrial life. In the high latitudes, permafrost stores vast quantities of frozen organic matter. As global temperatures climb, thawing releases methane, a greenhouse gas far more potent than carbon dioxide, potentially accelerating climate feedback loops beyond current projections. The planet's magnetic field, generated by the restless motion of molten iron in Earth's outer core, acts as a shield against solar radiation. Disruptions to this field can impair satellite communications, navigation systems, and increase radiation exposure for high-altitude travelers. Rainforest canopies host a staggering diversity of species, many still undiscovered. These ecosystems not only sequester carbon but also harbor genetic libraries that could yield future medicines, biofuels, and resilient crops in an era of ecological uncertainty. Urban heat islands illustrate how human development reshapes local climates. Concrete and asphalt absorb and re-emit heat, raising city temperatures by several degrees, which intensifies energy demand, air quality issues, and public health risks. Glacial melt contributes not only to sea level rise but also to the redistribution of nutrients in the oceans. Freshwater influx alters salinity gradients, impacting phytoplankton productivity and, consequently, the entire marine carbon cycle. Soil microbes act as the planet's unseen engineers, breaking down organic matter, fixing nitrogen, and supporting plant growth. Disruption of these communities through overfertilization or pesticide use can diminish soil fertility and release stored carbon back into the atmosphere. Coral reefs, often called the rainforests of the sea, depend on a delicate symbiosis between coral polyps and zooxanthellae algae. Rising sea temperatures cause bleaching events, eroding biodiversity and threatening coastal protection that reefs naturally provide. The carbon cycle is not a static loop, it is a dynamic system influenced by human activity. Deforestation, fossil fuel combustion, and land use change accelerate carbon fluxes, overwhelming natural sinks and reshaping atmospheric chemistry. Renewable energy technologies, solar, wind, tidal, draw directly from Earth's natural processes. Their deployment reduces reliance on carbon-intensive fuels, yet each must be integrated thoughtfully to preserve ecosystems, migratory pathways, and cultural landscapes. Ultimately, the story of Earth is a narrative of interconnection. From the microscopic algae in the sea to the vast tectonic plates beneath our feet, every component influences the whole. Recognizing this web compels us to act with humility, foresight, and stewardship.